Okay, so I received the homework from Atif and Sef. And what about Abdur and Masiha? You have completed the homework? Masiha and Sef. Sorry, Masiha and Abdur. You have completed the homework? Masiha? No? Masiha, but you have a complete week for this. Uh, please complete the homework on time, okay? And what about Abdur? You have completed the homework? Abdur, you have completed the homework? And Shiva, my voice is audible? Okay, so Shiva, you have completed the homework? Okay, then please share the homework with Nishkash sir, okay? I didn't receive your homework. Okay. Okay, then we will continue our last topic. So in last topic, we have started the transpose. Please let me know, we have completed this question. If A is a matrix satisfying this condition, then find the values of A and B. We have completed this?
Yes, sir.
Okay. Okay, that's great. Okay, then we will start the next topic. Okay, next is a symmetric matrix. So what is mean by symmetric matrix? If A is a square matrix, then it is called symmetric if Aij is equal to Aij. Okay, so we will check that what is the meaning of this definition. Just give me a minute. Please check here. Suppose we have, just now suppose we have this matrix. A is equal to 1, 2, 3. Let this be 4. This is 4. This is 5. This is 5. And this is 6. This is 6. Okay. So what is this symmetric matrix? This is called a symmetric if Aij is equal to Abi for all Aij. Okay. And also that A transpose is equal to A. Okay. So please remember this. A square matrix is said to be symmetric if A transpose is equal to A. So if we are finding the transpose of a matrix and we are again getting the same matrix, then we will say that matrix is symmetric matrix. So for example, in this matrix, if we will find the transpose of this, if we will find the A transpose, then we will get what? This is the first row. Now this becomes first column, A1, 4, 5. This is second row, this became the second column, 4, 2, 6. This third row, this becomes the third column, 5, 6, 3. Okay, now if we will compare this symmetric matrix with the original matrix, then we can say that A transpose is equal to A. Okay, so that's why this is called a symmetric matrix. So I hope this point is clear that what is a symmetric matrix? A matrix is said to be symmetric if A transpose is equal to A, and this is the condition. Okay, so if we are getting A transpose is equal to A, then we will say that this is a symmetric matrix. And in symmetric matrix, this condition always follows. Okay, we will check later on that what is this condition. Okay, so please remember, matrix is said to be symmetric matrix if A transpose is equal to A. Please remember this, A transpose is equal to A, then we will say that the matrix is symmetric matrix. Okay, now, if we will check the elements over here, then first thing, the symmetric matrix should always be a square matrix. Okay, it should be a square. So we can see here that this is a square matrix. Now, if we will check this element, then this element is what? A1, 2. And if we will check this element, A2, 1, then these two are same. Similarly, this is A1, 3 and this is A3, 1. So these two are same. Similarly, this one, this is what A23 and this is what A32. So these two are same. Okay, so what happened in symmetric matrix? In symmetric matrix, these two are same. A12, we can say that A12 is equal to A21. This one we can say A13 is equal to A31. We can say this one A23 is equal to A32. So in symmetric matrix, this conditions follow. This condition follow that A12 is equal to A21. Okay, so you need to remember only this definition that A transpose is equal to A. In such case, the matrix is said to be symmetric matrix. And in this symmetric matrix, this condition always follow that these two elements are same, these two are same, and these two are same. Okay. Now we can see one more example. For example, we have this matrix here. If you will find the transpose of this matrix, A transpose, then what we will get? This is the first row, this becomes first column. This one becomes second column, -1, 1, 4. This becomes third one, -3, 4, 2. So if we will check this A transpose, then this is equal to A. That's why we will say that this is a symmetric matrix. Okay, this clear to everyone? Atif, Abdur, Maziha, Saf, Shiva, please confirm.
Yes.
Okay. And all the other students, please reply me on the chat box. Okay, Maziha, good. Okay, Shiva. What about Saf, Abdur? This clear? Saf and Abdur, this is clear. Okay, Saf. Okay, Abdur, very good. Okay, so please note down this definition and confirm me, then we will start the next topic. Okay, you can note down only one example. There is no need to note two examples. Just note down any one of these. Shall we start next? This done? Okay, sure, very good. Atif, Abdur, Mazia, Saf, please confirm. Shall we start next? Okay, Abdur. Atif, Maziha, Saf, shall we start next topic? Okay, Atif, good. Maziha, shall we start next? Okay, very good. Okay. Now next one. Next is a symmetric matrix. Okay, sorry, a skew symmetric matrix. So what is a skew symmetric matrix? A square matrix is a skew symmetric matrix if I will write over here. Okay, just add this point. A transpose is equal to minus A. Okay, so please remember this. A square matrix is a skew symmetric matrix if A transpose is equal to minus A. Okay, and then this Aij is equal to minus Aj for all I and j. Okay, so please remember this. What is a skew symmetric matrix? A square matrix is said to be skew symmetric matrix if A transpose is equal to minus A. In the previous case, in this symmetric matrix, we have A transpose is equal to A. In a skew symmetric matrix, we have A transpose is equal to minus A. Okay, and we have this condition Aij is equal to minus Aj for all I and j. So we will check a matrix. We will take example. We have this matrix. Let this be 0, 0, and 0. Let this be 2, this be minus 2. Let this be 4, then we have a minus 4. Let this be 3, we have a minus 3. Okay, we have this matrix. Now we will find the transpose of this, A transpose. Then what will happen? The first row, this becomes the first column. So 0, 2, 4. Next one, minus 2, 0, 3. Next one, minus 4, minus 3, 0. Okay, so we get this matrix. Now what we can do, we can take out the common negative minus common from all the elements. Okay, so if you will take a minus common from all the elements, so the sign will change. This becomes 0, this remains 0, this becomes 2, 4, this becomes minus 2, 0, 3, this becomes minus 4, minus 3, and 0. Okay, if we will check this A transpose, then this is what? This is the original matrix. Okay, so if we are getting A transpose is equal to minus A, then we will say that this is a skew symmetric matrix. Okay, in symmetric matrix, we have A transpose is equal to A. In skew symmetric matrix, we have A transpose is equal to minus A. Now, please check this condition. We have seen here that all the diagonal elements are 0. Okay, so this is also the condition of skew symmetric matrix, that in skew symmetric matrix, all the diagonal elements are 0. Okay, please remember in skew symmetric matrix, all the diagonal elements are 0. We will discuss this point again after some time. Now we will check this condition, that what is mean by this one. Aij is equal to minus Aji. So if we will check this element, this is what? First row and second column. And this is what? A21. This is what? A13. This is what? A31. This is what? A23. This is what? A32. Now, if we will check these two elements, 2 and minus 2, then we can say that A12 is negative of A21. Similarly, A13, we can say this is negative of A31. Similarly, we can say A23, this is negative of A32. Okay, so in skew symmetric matrix, A12 is equal to negative of A21, A13 is negative of this, and A23 is negative of this one. That's why we can say this condition that Aij is equal to minus Aji. Okay, so what is a skew symmetric matrix? Where A transpose is equal to minus A, and this condition always follow that A12 is a negative of A21. So we can check here. This is the negative of this. 4 minus 4, 3 minus 3. So whenever you need to create a skew symmetric matrix, then first condition you need to remember is all the diagonal elements should be 0 and these two should have opposite sign. Then you will always get a skew symmetric matrix. Okay. Now for this one, we will do a proof that why the diagonal elements of a skew symmetric matrix is always 0. Okay. Now we have this Aij is equal to minus Hai. If we will put I is equal to j over here, in this condition, if we will put I is equal to j, then this will become Aii is equal to minus Ai. In this condition, we have replaced j with I, so we get this Aii is equal to minus. Now shift this part to the left side. Shift this part to the left side, then what you will get? You will get 2Aii is equal to 0. Okay, then shift this 2 to the right side, you will get a 0. So that means we are getting Aii is equal to 0 for all I. So what does this mean? If we will put the any number in place of this, for example, if we are putting 1 in place of I, then second number should also be 1. So we get 0. Similarly, A22, 0. Similarly, A33, 0. Now, what these elements represent? These elements always represent the diagonal elements. Okay, these are the diagonal elements. So we can see that in a skew symmetric matrix, the diagonal elements are always 0, and these elements are of opposite sign. So this is the condition for a skew symmetric matrix. Okay, so this means that all the diagonal elements of a skew symmetric matrix are 0. Okay, we can check this example. We have this 0, 0, 0. These have the opposite sign. So this is a skew symmetric matrix. This is clear to everyone. Symmetric and skew symmetric matrix. This clear?
Yes.
Okay, very good.
Yes.
Okay, good. Mazia, Saf, Abdur, this clear? Mazia, Saf, and Abdur, this clear? Okay, very good. Okay, good. Okay, so please note down this and confirm me. Then we will try some questions on the basis of this topic. Okay. Okay, Shiva, very good. And all the other students, please confirm me. Then we will start some questions on the basis of this topic. Atif, Abdur, Maziha, Saf, this done. Shall we start next? Atif. Okay, Maziha, good. Atif, Abdur, Saf. Okay, Saf. Okay, okay. Atif and Abdur. Shall we start next? Okay, Abdur, very good. Atif, please confirm so that we can start next. Okay, Atif, very good. Saf, shall we start next? Saf. Okay, very good. Okay, so we have done two topics. First is symmetric matrix. So what is a symmetric matrix? A transpose is equal to A. Second, we have discussed skew symmetric matrix where A transpose is equal to minus A. Okay, and we have done these conditions. Okay, now this question is from NCERT exemplars. If this matrix is a skew symmetric matrix, find the values of A, B, and C. Okay, so please try this question and share your answer. This is a very simple question. Okay, Shiva, very good. B is correct. Everyone, please share your answer if this is done. This is a very simple question. Okay, Atif A is correct, B is correct, and C is also correct. Very good. Saf, very good. This is correct. Good. Abdur A is minus. Shiva, very good. This is correct. Abdur, what is B? This is skew symmetric matrix. Okay, so what is B here? Acha, B you have already done. Okay, okay. So Abdur, what is the value of A? What is the value of A? Why you have written minus A? Very good, Shiva. This is correct. Observe, these two should be of opposite sign. So what is A? A is equal to minus 2. These two should be of opposite sign. So C is equal to minus 3 and B is equal to 0. Observe this clear? Okay, very good. Okay, so this is your answer. Now please try this one. This is a skew symmetric matrix. Okay, this question came in CBSE 2020. This is a skew symmetric matrix. Then please find the value of A plus B plus C whole square. Okay, please find the value of A plus B plus C whole square. Everyone, there's a same type of question. So please, Shiva, very good. This is correct. Atif, very good. This is correct. Abdur Masiha Saif, what's the answer? Abdur Mazia and Saif, what is the answer? Very good, Saif. This is correct. Abdur and Maziha. Very good, Abdur. This is correct. Maziha, what's the answer of this? Maziha, what's the answer of this one? Okay, and there's one more point that from this year, there are chances that there will be no term 1 and term 2. Okay, so there are chances that from this year we have only a single exam which will occur in March next year. Okay, so that term 1 and term 2 concept will most probably will not be there in this year. CBSE has not released their syllabus yet. Okay, so we will again discuss about the syllabus once they will release it. And you all already aware that last year they have reduced the syllabus. Okay, they have cut the syllabus by 30%. So most probably the same pattern will be there in this year. Okay, I will discuss the syllabus with you again once they will release it. Okay, so Mazia, this is done. Maziha, please let me know if you have any doubt in this. Okay, so the answer is 0. Maziha, please check here. We need to find the value of A. So A is equal to 1 because these two should have opposite sign. B is equal to 0. Okay, and C is equal to -1. Now, if we will add these three, we will get 0. If we will do the square of that, we will get a 0. So answer is 0. Now, this one. Dash matrix is both symmetrical and skew symmetrical. Okay, this question came in CBSE 2020. Okay, which matrix is both symmetrical and skew symmetrical? The null matrix. Okay, so please note down this. null matrix is both symmetrical and skew symmetrical. So please note down this one. This question came in CBSE 2020. And one more thing before your exam, please revise all these questions which we are doing in our classes. Okay, you have to do the assignments, but please revise these questions also, because some questions are of previous year. Okay, and some questions are of NCERT examples. So please, before your exam, revise all these questions. This is done. Shall we start next?
Yes.
Okay. 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 So I'm just going to start next question. Please note down this one. Now we will start the next question. Okay. Hope everyone has completed this. Please let me know if anyone has not completed this question. Okay, so the next question is, this question came in CBSE 2016. Okay, and the question is, this matrix is given to be symmetric. This is symmetric matrix. Now please find the values of A and B. Please find the values of A and B and share your answer. This is also a very simple question. Please complete this. Very good, Shiva, this is correct. Very good, Shiva. This answer is correct. Atif, Abdur, Maziha, and Saf, please share the answer of this question. Very good, Atif. This is correct. Abdur, Maziha, Saf. Okay, Abdur. So I guess 3 by 2 is B and minus 2 by 3 is A. Very good. Now Maziha and Saf, please share the answer. Very good. Saf, this is correct. Maziha, what is the answer of this one? Maziha, my voice is audible. Maziha, my voice is audible.
Yes, sir.
Okay,
Yes,
Maziha,
sir.
what's the answer? What is B and A?
A is negative 2 by 3 and B is 3 by 2.
Very good, very good. That is correct. Okay, so next we will start now the next topic. Okay, so next is we have a theorem that for any square matrix A with real number entries, A plus A transpose is a symmetric matrix and A minus A transpose is a skew symmetric matrix. Okay, this is a theorem that if we have any square matrix A and it have a real number entries, then A plus A transpose will be a this will be a always symmetric matrix, and A minus A transpose is a skew symmetric matrix. Okay, so what is symmetric? When A transpose is equal to A, this is a symmetric. And what is skew symmetric? When A transpose is equal to minus A, then it's a skew symmetric matrix. So what's the theorem? For any square matrix A with real numbers entries, A plus A transpose is a symmetric matrix and A minus A transpose is a skew symmetric matrix. Okay, this theorem is clear to everyone that A plus A transpose, but the condition should be A should be a square matrix. So A plus A transpose is a symmetric and A minus A transpose is a skew symmetric matrix. Okay, so we will do the proof of this. We have assumed that let B is equal to A plus A transpose. Okay, now we have find the transpose of this. So what does that mean? A plus A transpose, complete transpose. Okay, first we have assumed that B is equal to A plus A transpose. From where we are getting A plus A transpose? From here, because we need to prove first this symmetric part. So we have assumed B is equal to A plus A transpose. We have find the transpose of B, so we get this one. After this, we have find the, open the bracket. Okay, this property we have already done. Okay, we have already done this property that P plus Q transpose is equal to what? P transpose plus Q transpose. This we have already done in the transpose topic. Now, if you are finding the transpose of this, then what you will get? So you will get here A transpose plus A transpose, complete transpose. Now this A transpose remain as it is. And what is A transpose? Again transpose, this is equal to again A. So we get this, that B transpose is equal to A transpose plus A. Okay, now what is A plus A transpose? This was B. So we get from here, this is equal to what? In place of this, we can put B. So we are getting B transpose is equal to B. That's why we will say that B is a symmetric matrix. This point is clear to everyone? Please confirm.
Yes.
Okay. Okay, Shiva. Abdul Mazia Saf, this point is clear? Abdul Mazia and Saf, this point is clear? Okay, Saf. Abdul and Mazia? Okay, Abdul, good. Mazia, this is clear? Mazia, this proof is clear, the first point? Okay, Mazia, very good. Okay, so if this point is clear, then please do the second part on your own. Please prove this. A minus A transpose is a skew symmetric matrix. Okay, assume anything. Okay, let C is equal to A minus A transpose and try to prove this and confirm me once this is done. Okay, please let me know once it is completed, or if you're facing any issue, then please let me know. Okay, Shiva, very good. Okay, Atif, Abdul, Mazia, Saf, please check here if you're facing an issue over here. Let C is equal to A minus A transpose. Then we need to do the same thing. We will take the transpose of C. We get this. Okay. And from here, we will get what? A transpose minus A transpose whole transpose. So this will give you what? A transpose minus A. And from this, you can take negative common. Now, what is this? This is again C. So in place of this, you can put C. Okay, so you get C transpose is equal to minus C. Therefore, this is a skew symmetric matrix. So always remember A plus A transpose is a symmetric matrix and A minus A transpose is a skew symmetric matrix. This clear to everyone? Atif, Abdur, Mazia, Saf, this clear?
Yes, sir.
Okay, then please note down this, confirm me, then we will start the next topic. Okay, so all of you, please note down this and confirm me. Okay, Shiva, very good.
So my name is pronounced as Shravya.
Sorry, can you message me? I'm sorry. Can you please pronounce it again?
Shravya.
Shravya. Okay. Sorry. Okay, Atif. Good. Okay, Saf. Very good. Now, Maziha and Abdul, this done. Okay, Maziha. Very good. Abdul, this done. Okay, okay, great. Okay, so this theorem is clear to all of you. Now, the second theorem. Okay, so the second theorem is any square matrix can be expressed as a sum of symmetric and skew symmetric matrix. This is an important theorem. Most of the time, a question came from this topic. Okay, so the second theorem is any square matrix can be expressed as a sum of symmetric and skew symmetric matrix. Okay, if we have any square matrix, then we can express it as a sum of symmetric and skew symmetric. Okay, so we can break a matrix. If we have a square matrix, we can break that matrix into two matrices. First, we can say a symmetric, and second, we can say a skew symmetric matrix. Okay, so we will do a proof of this one. Let A be a square matrix, then we can write in this form: 1 by 2 A plus A transpose plus 1 by 2 A minus A transpose. Okay, so any matrix A can be written in this form. We will check here. If we will take the LCM here, then what we will get? A plus A transpose plus A minus A transpose. So this cancel out. We finally get 2A by 2. This is equal to A. Okay, so that's why A can be written as 1 by 2 A plus A transpose plus 1 by 2 A minus A transpose. Okay, so I hope there is no doubt in this point, because if we will take the LCM and simplify this, we will again get A. Now, who can tell me? Atif. Atif, can you tell me this matrix is what? This is a symmetric matrix or a skew symmetric matrix?
Symmetric matrix.
This is a symmetric. And what is this?
Skew symmetric.
Skew symmetric. So that's why what we have done, we have broken this A into two matrices. Just give me a minute. So we have broken this into two matrices. First is a symmetric matrix and second is a skew symmetric matrix. So this is the theorem that any square matrix can be written as the sum of symmetric matrix and skew symmetric matrix. Okay. So we already know that this is a square matrix and this is a symmetric matrix. This is a symmetric matrix. Okay, and this is a skew symmetric matrix. So I hope this theorem is clear to everyone that we can express a square matrix as the sum of symmetric and skew symmetric matrix. Okay, so please note down this theorem and confirm me, then we will do a question on the basis of this topic. Okay, Shravya, this is okay, good. Atif, Abdur, Maziha, Saf, please confirm me once it is done. Okay, Maziha, very good. Abdur, Saf, Atif, please confirm if this is done. Okay, why we are taking 1 by 2 on Abdul, we are not taking 1 by 2 on both sides. Okay, we have taken 1 by 2 only on the right side. So why we have taken this? So that we will again get A. Okay, first thing we need to see that what is the final result we are expecting. We are expecting two matrices. First is a symmetric and second is a skew symmetric matrix. Okay, Abdul. So we need this result. Why we have taken 1 by 2? Because when we add these two, then we are getting 2A. So we must divide this with 2 so that we get a A. This clear? Saf? Sorry, Abdul. We have taken 2 so that it will divide 2. Okay. Then we will start a question on the basis of this. Now, the question is express matrix P as a sum of symmetric and skew symmetric matrix. Okay. So we have this matrix P. We need to express this as the sum of symmetric and skew symmetric matrix. So what we need to do, we need B transpose. Okay. So how we will do this question? We will convert this question into this form. So for this, first of all, we will find B transpose. B transpose will be what? 2 minus 2 minus 4. Next is minus 1, 3, 4, then 1, minus 2, minus 3. Okay, we have find the transpose of this. Now, what we need B plus B transpose. So this will become what? 2 minus 2 minus 4 minus 1, 3, 4, 1, minus 2, minus 3. Okay, plus B transpose. What is B transpose? B transpose is 2 minus 1, 1, minus 2, 3, minus 2, minus 4, 4, minus 3. Okay, add these two, then what we will get? This 2 plus 2, this will give us 4. This will give us minus 3. This will give us minus 3. This is again minus 3. This is 6. This is 2. This is minus 3. This is 2. This is minus 6. We get this one. Okay. Now we will divide this 1 by 2. Okay. B plus B transpose. We will divide this with 2. So here we will get what? Here we will get 2. Here we get a minus 3 by 2. Here we get a minus 3 by 2. Here we get again minus 3 by 2. Here we get a 3. Here we get a 1. Here we get a minus 3 by 2. Here we get a 1. Here we get a minus 3. Okay. So please check here. B plus B transpose, we get this. Now what we have done, we have divided this with 2. So divide all the elements by 2. So you get 2 minus 3 by 2 minus 3 by 2 and so on. So we get this one. Okay. Now we know that this is a symmetric matrix. Okay, we know that this is a symmetric matrix, but we need to prove it. So what we will do, we will let P is equal to 1 by 2 B plus B transpose. We have assumed that this one, that P is equal to this. Now P is what? P is 2 minus 3 by 2 minus 3 by 2. Okay, minus 3 by 2, 3, 1, minus 3 by 2, 1, minus 3. So we get this P. Okay, so we have checked from the beginning. We have first find the B transpose, then we have find the B plus B transpose, then we have divided this with 2. Why we are doing this? Because we already know that this complete is a symmetric matrix. We need to express a matrix into a symmetric and skew symmetric matrix. That's why we need this. Now, but we need to prove that this is a symmetric matrix. So what we have done, it is not convenient for us to always write this complete expression. That's why we have assumed that P is equal to this one. Okay, P is this. Now we will find the transpose of this one. So P transpose, we will get what? This is equal to, just find the transpose of this. First row become the first column. 2 minus 3 by 2 minus 3 by 2. Okay. Next is minus 3 by 2, 3, 1. Minus 3 by 2, 3, 1. Next is minus 3 by 2, 1. Minus 3 by 2, 1. And minus 3. Okay, so we get this P transpose. If we will compare this P transpose with P, then the matrices are same. These two matrices are same. Okay, So what we get, we can say P transpose is equal to P, hence P is a symmetric, P is a symmetric matrix. Okay, so this is clear to everyone. We will again revise it. We will check from the beginning. We have find the B transpose, then we have find the B plus B transpose. We have divided with 2. We already know from our previous theorem that this is a symmetric matrix, but we need to prove it. In exam, you need to prove this. So what you will do, you will take this as P and you will find the transpose of that. So you will get P transpose is equal to P. Okay, hence P is a symmetric matrix. Now next, what we need to find? We need to find B minus B transpose. Okay, because if we will check a previous theorem, then A plus A transpose by 2 is a symmetric and this is a skew symmetric. That's why we need to find A minus A transpose. Here we have a B, that's why we will find B minus B transpose. Now what is B? B is 2 minus 2, 4. 2 minus 2 minus 4. Okay, next is minus 1, 3, 4. Minus 1, 3, 4. 1 minus 2 minus 3. 1 minus 2 minus 3. Okay, minus B transpose. Now what is B transpose? We have already find out over here. So this becomes the first column, minus 2 minus 4. This becomes the second column, minus 1, 3, 4. And this becomes the next column, 1 minus 2 and minus 3. Okay, now B minus B transpose we have find out over here. Now subtract it. B minus B transpose. So this will give us what? 2 minus 2, this will give us 0. Minus 2 and plus 1, this will give us minus 1. Minus 4 and minus 1, this will give us minus 5. Here, minus 1 plus 2, 1. 3 minus 3 is 0. 4 plus 2, 6. Here, 1 plus 4 is 5. Minus 2 minus is minus 6. Minus 3 and this is 0. Okay. Now, what we will do, we will divide this with 1 by 2. So we will divide this with 1 by 2. So what we will get, B minus B transpose, this is equal to what? Divide all the elements with 2. So you get 0, minus 1 by 2, minus 5 by 2. This is 1 by 2, this is 0, this is 3, this is 5 by 2, minus 3 and 0. Okay. So we get 1 by 2, B minus B transpose is equal to this one. Now assume it. We already know that this is a skew symmetric matrix, but we need to prove it. Let Q is equal to 1 by 2 B minus B transpose. Okay, so this will give us what? Q is equal to this complete. 0 minus 1 by 2 minus 5 by 2. 1 by 2, 0, 3. 5 by 2 minus 3 and 0. We get this one. Now find the Q transpose. So Q transpose is equal to first row become the first column. So 0 minus half. Okay, minus 5 by 2. Next, this one 1 by 2, 0 and 3. Next is 5 by 2, minus 3 and 0. So Q transpose is equal to this. Now, if we will take a negative comment from this one, so we will get Q transpose is equal to take negative comment. So first row become first column, minus half, minus 5 by 2. Half, 0, 3, 5 by 2, minus 3 and 0. Now, if we will compare these two, then this is the same matrix. So we can say that Q transpose is equal to minus Q. Hence, Q is a skew symmetric matrix. Hence, Q is a skew symmetric matrix. Okay. So up to now, we have just show that P is a symmetric matrix and Q is a skew symmetric matrix. Okay. Now what we will do, now we will add P and Q. I will tell you later on that why we are adding these two. What is P? P is 2 minus 3 by 2 minus 3 by 2. 2 minus 3 by 2 minus 3 by 2. Okay. Minus 3 by 2, 3, 1. Minus 3 by 2, 3, 1. Minus 3 by 2, 1 minus 3. minus 3 by 2, 1 minus 3. Okay, plus. What is Q? 0 minus half minus 5 by 2. 0 minus half minus 5 by 2. Half 0, 3. Half 0, 3. 5 by 2. 5 by 2 minus 3 and 0. Okay. So P plus Q is equal to what? Just add these two. So you will get 0. Minus 3 by 2 and minus this. Minus 2. Minus 4. This one minus 1. 3. 4. This is 1. And this is minus 2. And this is minus 3. So if we will add P and Q, we will get this. Now we will check the original question. Okay, original question is what? First row is 2 minus 2 minus 4, which is same here. Minus 1, 3, 4, which is same here. 1 minus 2 minus 3, 1 minus 2 minus 3. So P plus Q, we will get what? This is equal to B. Okay. So P is a symmetric matrix, Q is a skew symmetric matrix. So we can say here P is a symmetric. Just give me. Here P is a symmetric matrix. And Q is a skew symmetric. Just sorry, Q is a skew symmetric matrix. Okay, hence B can be expressed as the sum of symmetric and skew symmetric matrix, as a sum of symmetric and skew symmetric matrix. Okay, hope this is clear to everyone. This clear? Please confirm. Atif, Abdur, Maziha, Saf. Okay, Shriva, this is clear. Okay, very good. Okay, so I'm changing the slide. Please note out this and confirm me once it is done, so that again I will start the another slide. Okay, please note down this and confirm me. And let me know if anyone have a doubt in this question. Bishravia, good. Atif, Abdur, Maziha, Saf, this done. Shall I change the slide?
1 minute.
Okay, okay. Whoever has completed this slide, please let me know in the chat box. Everyone, please confirm me on the chat box. Okay, Saf, good. Masiha, Abdur, Atif. Masiha, Abdur, Atif, that's done. Shall I change the slide? Masiha, okay, Masiha, good. Atif and Abdur, this done. Atif and Abdur. Okay, Abdur, this done. Abdur, shall I change the slide? Okay, good. Now please note on this one. Okay, everyone, please confirm me on the chat box once this is done. Okay, Shravya, good. And all the other students, please confirm me if it is done. Okay, Mazia, very good. Okay, Atif, Saf, very good. Abdur, this is done. Shall we start next? Okay. Please note down this and confirm me once it is done. Okay. And if anyone have a doubt in any of the steps, then please let me know. Everyone, please confirm me once it is done so that we can start the next topic. Okay, Shravya, good. Atif, Abdur, Maziha, Saf, please confirm me once it is done. Okay, Abdur, Maziha, good. Okay, so I guess everyone has completed this. Saf, this done? Okay, great. Just give me a minute. Okay. Now our topic is question based on application of matrices. Okay. So we will check the first question. Now we have checked that what is a matrix, how can we multiply two matrices, how can we add two matrices. Now we will do the application of the matrices. Okay, we have this word problem. We will solve this word problem by the use of matrices. Okay, so the problem is use matrix multiplication to divide rupees 30,000 into two parts such that the total annual interest at 9% on the first part and 11% on the second part amount rupees 3060. Okay, in your exam there's a possibility for such type of questions. Okay, we will share one more assignments with you where there are question on the basis of application. Okay, now in these types of questions, I always suggest the students that before making a matrix, please first of all clear the point that what equation you need in the end. Okay, so what is the question? You have a 30,000 rupees. You need to break this amount into two parts. Okay, for example, first amount we have taken as x, second amount we have taken as 30,000 minus x. We need to break this amount into two parts, x, and second we have taken 30,000 minus x. Now the interest on the first part, the annual interest on the first part is 9%. On the second part, okay, add this one, the interest is 9%. annual interest, and on this part, interest is 11%. Okay, and they're saying use matrix multiplication to divide this into two parts such that total annual interest at 9% on the first and 11% on the second parts amount rupees 3060. So this is the total interest. This is the total simple interest. Okay, so total simple interest is 3060. Now everyone know the formula of simple interest. What is simple interest? P into R into T by 100, where P is the principal, R is the rate of interest, T is the time, and 100 is because of this rate percent. Okay, everyone is aware about this formula. So what we need to do over here, we need to find the simple interest on this amount, we need to find the simple interest on this amount, and we need to equate that with 3060. Okay, so principal we have first. Okay, now this part you need to do in the rough, on the rough page. Okay, there is no need to represent this part. So before making any matrix, please make an equation in the rough part so that you will have an idea that of which order you need to make the matrix. Okay, so first equation, what we need the principal, which is x. What is the rate? Rate is 9% on the first part. Time is annually. They are saying annual interest, so we are taking this one by 100. Okay, so first we need this. Second, we need to apply the interest on this 30,000 minus x into 11% into 1. Okay, I will write 11% over here. Okay, by 100, we will do this later on. %9 into 1. Okay, 11% into 1. So this is the interest. We need this equation in the end, and we need to add these two equations. So what we need to do, we need to make a matrix. Now, for the principal amount, we have these two amounts. So we can make a matrix like this. Let A is equal to, suppose we have two options. We can make a matrix like this, x and 30,000 minus x. Okay. Or, okay, I will ask you that which matrix we need to select. Okay. Or we can make this matrix 30,000 minus x. So we can have this matrix or this matrix. Now similarly, rate of interest with R. Now, what is the rate of interest? The rate of interest we can represent like this, 9% and 11%. Or we can represent the rate of percent like this, 9% or 11%. Okay, 9% and 11%. Okay, now we need to multiply these two matrices, and okay, and final result, what we need the final result, this one, addition of these two. Okay, so the order of this one is what? 2 rows and single column. This is what? 3 rows, sorry, so 1 row and 2, and this is what? 2 rows into 1, and this is what? 1 row into 2. Now anyone can tell me that which matrix in principal and in rate of interest we need to select, so that we will multiply them and we will equate that with 3060. Okay, so we will write like this: simple interest is equal to, we will multiply two matrices. Anyone can tell me that which matrix we need to select?
Sir, for first one,
Yeah.
we'll take the first one. 2
Okay.
into 1, 2 rows, 1 column.
Okay.
Then for rate of interest, we'll take the second one, 1 by 2.
1 by 2. Okay, Shravya, we will check that your answer is correct or not. Anyone else? Abdul, Mazia, Saf, Atif. Any idea which matrix we can take? we have already checked over here, okay, that what we need the addition of these two. So this is only a single element. This complete part, this is a single element. We need this. Finally, we need this x into 9% into 1, or we can ignore 1, x into 9% plus 30,000 minus x into 11%. Finally, we need this because we need to equate this with the simple interest 3060. So we just need a single element. We don't need 2-3 elements. Finally, we just need a single element. Okay, so we have checked that we have these options. So anyone else, because for multiplication, k number of columns should be same.
So for
Okay,
A, we need to take 1 by 2.
1/2. Okay, so this is Atif. Okay, Atif. And for
And
next one?
for R, we need to take 2 by 1.
Okay. Okay, I got two answers. Then Abdur, Maziha and Saf, can you share your answer? Which matrix we can take? Abdur, Maziha and Saf, you can guess. If you are not able to understand at this moment, then please guess your answer. Abdur, Maziha, Saf. Okay, Saf. 2 by 1 and 1/2. Okay, Saf, so your answer is same as of Shravya. Okay. Okay, and Abdur and Maziha? Abdur and Maziha? Please, Maziha 2 by 1. Okay. And what's the next one? Maziha, what's the next one? Okay. 1/2. Okay, Maziha. So you are saying that from the first matrix, we will take this as the first. And from second one, we will select this one. Okay. So who is remaining? Abdur. Abdur? Abdur, can you share your answer? From the first one, which matrix we can select? Abdur? Abdur, please share your answer. Okay, if you have a doubt in this, then please guess. Okay, you have two options. Just tell me, just guess your answer. Abdur. Okay, please check here. This is matrix A and this is matrix B. Okay, Shravya and Maziha and Saf. Saf. You have given me this answer that select this as a 2 by 1. Okay, and B is as a 1/2. So now, if we will multiply this, suppose we are getting a matrix C. If we will multiply these two, then what is the order of this? 2 by 2. So this C have 4 elements. We don't need 4 elements. Okay, we have a simple interest. So finally, we need only a single element. This clear? So you need to do the word problem like this. So you need to check that what result you need first. So result, we need this. We just need a single element. So we will not use this one. Okay, Atif answer is correct. Now suppose in the matrix A, if you will select this 1/2, and in the matrix B, you will select a 2 by 1. If you will 2 by 1, okay, if you will multiply these two, then you will get C, which is 1 by 1. So this answer is correct. So for the simple interest, what we will do, we will select this one. X 30,000 minus X. Okay. And in B, we need this one, 9% and 11%. Okay. So you just need to multiply this, equate this with a simple interest, you will get the answer. Okay. So in exam also, first in the rough part, you please check that what final result you need. As per that result, please choose the matrix. Okay. So in exam, there is no need to write so many of options. So just write this one. So A, we need this part. So remove this. Okay. Let A is equal to this, and R, you need this. So remove this part. Okay. So just write let A is equal to this, let R is equal to this, simple interest is equal to this one. and then you need to multiply the two matrices. Okay, so we will complete this question. This multiply this, simple interest is equal to, how can we multiply two matrices? First row, first column. So x into this 9%, 9% of x. Okay, so 9 by 100 into x plus 11 into this one, 11 by 100 into 30,000, 30,000 minus x. So this is the complete matrix. Okay, now how can we solve this? Simple interest is what? 3060, and this is equal to this one. Okay, so just take the LCM. So here we will get a LCM 100, and this is what? This 9x plus, okay, 33 minus 11x. Okay, and this is equal to 3060. Wait. So here we get this, simple interest is equal to this, simple interest is 3060. Now we will remove the matrix because we are comparing this with a real number. So here we will get 330,000 minus 2x by 100. Okay, cross multiply. So 3060 is equal to 330 minus 2x. Shift this to the left side. So 2x is equal to 330 minus 306. So here what we will get, 330 000, then 306 000. Okay, so 0. Here we will get 4. Next here we will get 2. So we get 2x is equal to 24,000, and here we will get x is equal to 12,000. Okay. So in this question, what we need to find? We need to find the first and second part. Okay. So first part we get this. What is the second part? Second part is equal to 30,000 minus x. So this will give us 30,000 minus 12,000. Okay, so this will give us 18,000. So this is your second part, and this is your first part. Okay, so first part is 12,000. Okay, so I hope this is clear to everyone. Atif, Mazia, Saf, and Shravya, this clear?
Yes, sir.
Okay, very good. Okay, so in word problem, please first of all check that what final result you need. Okay, and as per your result, please make the matrix. So please note down this. And okay, today you have a Viva. Okay, so please note down this, and then we will start a Viva. Let me know once it is completed.
Sir, can you explain again how should we estimate how a matrix should be?
Oh, yes. Seth, first of all, whatever the result you need, please write that in the rough part. Okay, it is not possible for you to directly make a matrix. Okay. So in rough, we will check that what we need. If we will check this question, then we need the simple interest, because the simple interest is given. This is your principal. We need to divide this amount into two parts, x and this. So we have checked that what is the formula of simple interest. So this is the formula. Principal into rate of interest into time plus principal into rate of interest. So we need to add this, and we need to equate this with the simple interest. So in rough part, we get the picture that finally we need this equation. Okay, now the principal amount, for the principal amount you need to make a matrix, and for the rate of interest you need to make a matrix. So how can you make a matrix? First of all, we have checked all the options. that for the principal amount we only have two options, 2 rows or 1 row. Similarly, for the rate of interest, we have 2 rows and or 2 columns. We only have these options. Now, if we will check our result, then in our result, we have only a single equation. So that means whatever the matrix we will choose, when we will multiply the two matrices, we need only a single element, that finally we need the order 1 by 1. Okay, from this equation, we get to know that finally we get a matrix having the order 1 by 1. Okay, so what we will do, we will select a matrix A, we will select a matrix B, and we will write a matrix C. Now we need the C of the orders 1 by 1. Okay, now we will check that what will be the order of this one. Now please check here. Here we have a 1. So for the B at the last, we have 1, and A starting we have 1. Okay, then we have only 2. So write this 2 and 2. This clears, Saf?
Yes, sir.
Okay, very good. This completed. Shall I change the slide? Saf?
Yes, sir.
Okay, great. Now please note down this, confirm me, then we will start our Viva. Everyone, please confirm me on the chat box once you will complete this. Okay. Okay, sure, we are very good. Okay, Atif, good. Mazia and Saf, please confirm me once it is done. Okay, Mazia, very good. Saf, this done. Shall we start next? Okay, very good. Okay, so please note down the homework. Homework is up to assignment 3rd. Okay, you need to complete assignment 3rd. 2nd, you have already completed. So please complete assignment 3rd. Okay, just give me a minute. So just give me a minute. Okay, so Seth, the first question is for you. What is a row matrix?
A matrix that has only one row.
Okay, what is a square matrix?
A matrix that has equal number of rows and columns.
Very good. And what is a diagonal matrix?
A diagonal matrix is a matrix that the diagonal elements are equal.
Very good. The diagonal elements are equal. No, this is not a diagonal matrix. Okay. So 2 questions are correct. First is wrong. 1 is wrong. Okay. Okay, Seth, if you wish, you can drop off. Okay. We will continue the topic tomorrow. Okay. And
Thank you, sir.
you're welcome. Okay, Atif, what is a diagonal matrix?
A diagonal matrix is a square matrix in which all non-diagonal elements are 0.
Yeah, very good. Perfect. Now, next is what is a scalar matrix?
A scalar matrix is a diagonal matrix in which all diagonal elements are equal.
In which diagonal elements are equal. Very good. What's the identity matrix?
It's a scalar matrix in which all diagonal elements are unity. That is 1.
Diagonal elements are unity. Very good. Okay, Atif, very good. Next question is for you. Just give me a minute. Shravya, next question is for you. In which case we can multiply two matrices?
So we can multiply two matrices if the number of columns of both the matrices are equal.
Only number of column? No, that's not correct.
Sir, number of columns for multiplication of matrices.
Yes, the number of column of the first matrix and number of rows of the second one.
Yes, sir. Yeah. The
Okay.
number of columns of first matrix and the number of rows of second matrix. And the resultant would be number of rows of first matrix into number of columns of second matrix.
Yes, very good. And in which case we can add two matrices? What should be the order of both the matrices?
Sir, for addition of matrices, it should be A of Aij is equal to, suppose we have two matrices like A of Aij and B of Bij. So in such cases, we can add two matrices.
Okay.
Like the order of M and N and the other of two matrices is added by corresponding matrix of element A and B.
Yes. In other words, we can say the order of both the matrices should be same.
Yes, sir.
Okay, very good. And does matrix addition follow commutative property?
So could you repeat again?
Yes. Does matrix addition follow commutative property?
Yes, sir. Matrix. Yes, sir.
Okay, very good. Very good, Shravya. Okay, if you wish, you can drop off. We can continue the topic tomorrow. Okay.
Thank you, sir.
Okay, welcome. Okay, Mazia, next question for you. Does matrix multiplication follow commutative property?
Yes, sir.
Follow commutative, that means AB is equal to BA. That is correct?
No, sorry.
Okay. Next is if multiplication of two matrix is a null matrix, then is it necessary that both A and B should be a null matrix?
Yes.
If we are multiplying two matrices A and B and we are getting a null matrix, then is it necessary that both should be a null matrix, or is
one can be different.
okay, very good. Okay, please tell me, is it true or false if A and B are two matrices such that AB exists? Okay, if A and B are two matrices such that AB exists, then BA may or may not exist. Is this correct?
Sorry, I didn't get it.
Yes, if A and B are two matrices, okay, we are multiplying A and B, okay, and we are saying that AB exists, that multiplication of A and B is possible, then is it necessary that BA also exists? If AB exists, then is it necessary that B exists?
Yes.
No? Okay,
Yes.
if AB exists, then it is not necessary that B exists. Okay, we will take example. Okay, just give me a minute. Okay, suppose A have the order 3 by 2, B have the order 2 by 3. Okay, then AB exists. Or write this as 2 by 1. Okay, so 3 by 1 we will get. But can we multiply B and A?
No.
No. Okay. Okay, Mazia.